Now let's look at this. Write the structures of the following alkenes. We have first one is ethene, two is propene, and three is butanene. Let's start. You know, in the alkenes family, we always start from number two, ethene. We don't have methane, so we always start with ethene. Now, the alkenes family, or the homologous series of the alkenes have a formula, molecular formula of CnH2n. This is their formula. Now, this is the formula for calculating the members of, writing the formula for the members of the alkenes family. Now, there's also one hint I must also give us. Anytime you are writing any structure of the alkenes or the alkynes, always compare the formula of the alkenes with that of the alkanes. Now, this is what I mean. For example, we know that for number one we have ethene. Ethene is number two. And so if I'm writing this, I'm using this formula where n is 2. So I'm using CnH2n. So I'll have C2H2 times 2. So I have, because the n here is 2, this n here is 2. So 2 times n, 2 times 2. So I have C2H2 times 2, 4. This is what I have. Now, this is for the ethene. Don't forget that for ethane, the alkanes family, we have CnH2n plus 2. So, and it's the same thing as n is also 2. So if you write this, you're going to have C2H2 times 2 plus 2. You're going to have C2H2 times 2, 4, 4 plus 2. 2 times 2, 4, 4 plus 2, we have 6. This is what you're going to have. That's for ethene. Now, if you observe this closely, if you connect these two, you are going to see here you have 4 hydrogens, you have 6 hydrogens. So that means there are 2 hydrogens that are lost in terms of relating it with ethene and ethane. If I'm relating the two, you see that ethane has 2 more hydrogens compared to, it has 2 hydrogen higher than ethane. So if you're writing this, I'm saying this because this will always give you the idea on how to write the structures of the ethene. Now, we want to write that of ethene. That means we are going to take away 2 hydrogens. If you're writing the structures of the ethane, the structure of ethane, for example, if I'm writing that of ethane, ethane is, I'll have C, that's 2. I have one hydrogen, another hydrogen, another hydrogen, another hydrogen, another hydrogen. So 1, 2, 3, 4, 5, 6. Now, but for the ethene, which still n is still 2, here n is still 2. Now, for the ethene, look at this. That means here 2 hydrogens are lost. So what am I going to do? The alkenes have a double bond, and the hydrogen loss will always be between the carbons under consideration. Now, in this case, ethene is just one. So the loss of the hydrogen is going to be on the first carbon. It's going to be on the first and the second carbon. Of course, we also have 2 carbons here. So it's going to be in between this and this. So that means one hydrogen rather will be lost here, another one will be lost here. Don't forget that. One hydrogen will be lost from this first carbon, and another hydrogen too, one will be lost here. So the formula for ethene now is going to now be C double bond C. Don't forget the bond is going to be, because we're talking about ethene, so that means the bond is on the first 2 carbons. Okay, so we have hydrogen. How many hydrogen are we supposed to have for ethene? For ethene, they're supposed to be 4. So we already have 2. Now we have 1 here, we have 1 here. So we have 1, 2, 3, 4. So we have 4 hydrogens. The loss is going to be the first carbon is going to lose 1, the second carbon will lose 1 because the bond is between these 2 carbons. This is how the structure for ethene is going to be. This is the structure. Now, you might also want to, probably you want to change it to have something like C double bond C, hydrogen, hydrogen, maybe here hydrogen, here hydrogen 4. You might want to have it like this, but preferably you leave it like this instead of this. But even though like this, some will accept it, but it's better you leave it like this. This is for ethene. Now, if we go to propene, this can also be the same thing as prop1ene. That's propene. Now, which is still similar to this. For number 2, we have for propene. Propene, if we use this, we're going to have C. We have the formula CnH2n like this. So we're going to have C. Propane is N is 3. Propene. So we have C3H2 times 3. That's N is 3. So 2 times 3 is 6. I have 6. So we have C3H6. That is for this. Now I said always compare it with that of ethane, or that of the alkanes rather. So propane, for propane, which is N is still 3. We have going to be C, don't forget CH2N plus 2. Now we're going to have C3H2 times 3, 6, 6 plus 2. 6 plus 2, we're going to have 8 here. Now, if you observe the same thing, you're going to lose 2 hydrogens are lost. 2 hydrogens are lost. So that means for you to have ethene, you have to lose 2 hydrogens. Sorry, for you to have propene, you have to lose 2 hydrogens. Just as we said here, for me to have ethene, I have to lose 2 hydrogens from ethane. The same thing for me to have propene, I have to lose 2 hydrogens from propane. So the same thing, C3 carbon. Now, this is propene, prop1ene. Propene is just 1. So that means the loss of hydrogen is on the first and second carbon. This first carbon and the second carbon. So they are the ones that will lose the bond. We lose the hydrogen rather. So the double bond is going to be here. If you say prop, yes, we're going to move. I will still write other structures on this, but just understand this. So since it's here, the loss of hydrogen is going to be between these 2 because that's where the bond is. So this will lose 1 and this will also lose 1. So I can have hydrogen here. Hydrogen, don't forget we need 6 hydrogens. I can have 1 hydrogen here too. I can have another one here. I have another one here. So 1, 2, 3, 4, 5. I can have another hydrogen here. 6. So I have 1. I have 1, 2, 3, 4, 5, 6. So this is complete. This is how to write the structure for propene. Let's erase so that we do that of prop1ene. but1ene. Thank you very much. Okay, let's have that of but1ene. Now, number 3, butene. But1ene or butene. Now, the same thing, butene is, but1ene is number 4. So we have CnH2n, which is the same thing as C4H2 times 4, because N is 4. 2 times 4 is 8. You have 8. If you write that of butane, you still have 4. Butane is CnH2n plus 2. So we have C4H2 times 4, 8. 8 plus 2, 10. So the same thing, for you to get but1ene, you need to lose 2 hydrogens from butane for you to get that. And don't forget, this one means that the bond is between the first and the second carbon. So if I want to write the structure of this, I'm going to have C. How many carbons? 4. C. So it's going to be here. So the same thing. 1, 2, 3, 4, 5, 6. Have 7. We have 8 here. So this is what you have as this. So the loss of hydrogen is going to be shared between the first carbon and the second carbon, since it is both 1e. So imagine the question is changed and you have, let's say number 4, let's say you have both 2 in. For instance, you have both 2 in, not both 1 in. So if I have both 2 in, for example, I'm going to be having the same thing we're going to be having. We'll still have our structure going to be C4H8. So if you still compare it to this, if you compare it to this butane, you still have C4H10. So the same loss of 2 hydrogen. So the hydrogen is going to be second bond. So have C4. So it's going to be here. So the loss of hydrogen is going to be shared between these two. So this will have complete hydrogen. This will have complete hydrogen. So we're looking for 8 hydrogen. 1, 2, 3, 4, 5, 6. Going to be shared. So let's go. 1, 2, 3, 4, 5, 6, 7. So the loss of hydrogen is going to be between these two. So we also have 1 here. So this high carbon is supposed to have 2 hydrogen, so it's going to lose 1. This carbon is also supposed to have 2 hydrogen to lose 1, so that since the bond is between this second and the third, so we have 1, 2, 3, 4, 5, 6, 7, 8. This is the structure of both 2 in. Thank you for watching. Do not forget to like, to share, and to subscribe. Don't also forget that understanding connects us to the world.